Good morning, everyone, and welcome to our 12th Fusion Friday. My name is Alex Alvarez.
My name is Brian Mulford.
We're application engineers here at KETIV Technologies. So happy Friday, everyone. This is your first Fusion Friday. Just a quick overview on what Fusion Fridays are. It's a series of webinars, right, where we go over all the workspaces that Fusion 360 has to offer, as well as some of the updates that Autodesk has for Fusion 360.
Right.
So one of the most recent updates has actually been sheet metal, right? So it's not too recent. It's probably been out for a couple months now, since like late August, mid-August. So we did reach out to a couple customers now that they've had some time to use it, and we just asked them a couple questions. You know, how are you liking sheet metal? Any problems that you may be experiencing with the topic? So we decided to do a webinar based off of those questions or comments that we received from, right? So hopefully with this webinar, we are able to cover some of your questions. Again, feel free to ask any questions you may have during the presentation here in the chat box, right? So without further ado, I'll go ahead and pass it over to Brian and get this going.
Cool. Thanks, Alex. So just a quick reminder of who KETIV is. We're an Autodesk Platinum partner that provides training, support, and consulting for Autodesk products. And one of those products being Fusion 360. Now, Fusion 360 is an awesome software multi-tool that has CAD, CAM, simulation, and more. And the reason behind the creation of Fusion 360 was because a lot of the traditional tools are all multiple different tools and they're all disconnected. And Fusion solves that problem because it's all in one tool. Also, Fusion was created because it's able to utilize a lot of the modern technology we have today, such as the cloud.
Yeah, so along with the cloud though, right, you also have the simulation capabilities that come with that, right? So one thing that the cloud allows you to do is really use the computing power that it gives you, right? And now you don't have to really leverage your local resources. So you may or may not have an older computer, right, with some pretty bad specs. Why not use the power of the cloud and run those long simulations?
Right, and you can run multiple simulations at a time as well.
Exactly.
Same for rendering. You can run multiple renderings at a time. Here are some of the customers that use Fusions for their product designs. PetSmart, Kohler, Under Armour, to name a few. And if you guys can guess from the title, we'll be covering sheet metal today. And we'll be creating an outlet box. On the top right-hand corner of the screen there is what it's going to look like. And it holds like electrical wiring. Some of the topics we'll be going over today is the flange tool. And I'll show you guys how it's a 4-in-1 tool. We'll cover some sheet metal rules. I'll be giving you guys some tips on editing sheet metal. We'll be creating a drawing as well as camming the sheet metal that we created. So it's a lot of things going on today. So if you guys have any questions or comments, feel free to leave that in the chat room like Alex said. So let's go ahead and hop into Fusion here. Here is the sheet metal outlet box created in Fusion. Let's go ahead and open up our own new design and start that from scratch. So right now we're in the modeling workspace. And to get to the sheet metal workspace, you just go to sheet metal right here. And notice how a few tools did change. The freeform tool went away, and now we have a new component tool specific for sheet metal as well as flange. We also have the unfold tool, create flat pattern, and sheet metal rules. Now, to get started, let's go ahead and create a new component, and we'll name it outlet box. And we can also, while creating this new component, specify the units and the material that we want to use for this sheet metal component.
Mm-hmm. One key thing to remember is the golden rule, right, when it comes to Fusion 360. So when you are going to be starting a new design, it's very important that you start out by creating a new component, right? So a lot of the times we just simply, go straight to the sketch and start extruding our objects. But you guys have to keep in mind that you do have to create a component first, right? If you are going to be creating multiple components.
So then, yeah, to add on to what Alex was saying, once you add another component here and more, this will be an assembly for sheet metal. Okay, moving forward, we'll go ahead and create a simple sketch here of a 3x5 rectangle. And we'll go ahead and select the flange tool. And like I mentioned, it was a 4-in-1 tool. So the first tool that the flange does, or the feature that it does, is it creates a thickness in respect to the sheet metal rules, which we'll go over in a few minutes. And with this thickness, you're able to create it on side 1, you can create it on side 2, or you can create it symmetrically about the plane. And you can have the options between body and component. So simple enough. So that was 1 of 4. The second feature to the flange tool is its ability to create bends. So notice how there's a radius here, and that's once again in respect to the sheet metal rules that was specified in the aluminum inches units that I selected. You can also have the option to bend it forward and backward by using this tool here, or by entering a value. And you have the options for selecting how tall it's going to be. So for instance, if you select interfaces, it's going to be from this height here, or from this face here to the top of the flange face. And if you select outer faces, it'll be from the bottom face here to the top of the flange face as well. And that goes the same for the bend position, except it's going to be in the horizontal direction. Also, let me go back and edit that. Also notice how if I do it for, let's say, all 4 edges at the same time, it creates this gap that I can control once again in the sheet metal rules. And the purpose for doing it this way is if I wanted to make this gap a lot smaller, and then we can use this for welding actually. Also, so now we went over that it creates a thickness, it creates a bend, but the flange tool also creates a miter in between these, the sheet metal here. And what a miter is, it's a solution to the corners of your sheet metal. So notice how when I leave this miter option checked, it creates the miter for us. But if I leave it unchecked, it overlaps each other, and it even gives us a warning that they're intersecting. So then sheet metal can't be created out of this. So if I want to go ahead and leave the miter option checked, you can also bend this backwards to get a better visualization of what that would look like. So if I leave this unchecked, it would give you something like that. I can go ahead and check it. And lastly, the fourth tool in the flange tool is its ability to create some contour flanges. And what a contour flange is, it references a sketch that you create, as well as an edge. And notice how it connected the sketch to the edge. Even though my sketch didn't even connect to that edge, it found a solution for me, and it connected it. Even the corners, the sharp corners of my sketch here were rounded off based off that sheet metal rule. And these are used, contour flanges are useful for creating hems, especially. All right, so let's go ahead and create that box that you saw earlier, the outlet box. However, instead of a welding approach, we're going to do another approach that doesn't require us to weld it. I'll go ahead and set this height to 2. And then I'll select these other 2 faces. And notice how they're on a different level than the original flange that I created. Oops. So now notice how I created these separately, so then this one can later be, I'll later create a flange here that'll later encompass this inner flange there. So I'll go ahead and create this flange. Oh wait, before we do this, I'm going to go ahead and extrude out these faces just a bit so that they don't overlap to that next flange that I was going to create. It'll make more sense in a second. So just by 1/1000th of an inch, it'll come out. Sorry, I want to make sure these are at the right height. Looks like there we go. I want those to be on the same height here. Let me change that to, there we go. The height, I didn't specify the height there. Okay, cool. All right, now let's go ahead and create that flange that kind of hugs this inner flange here. Once again, it's giving me the error that it's intersecting or overlapping each other. I'm going to go ahead and change this to the outside bend position so that they no longer intersect. And there's that one, that's why I created that extrusion, so that I can have a 1/1000th of an inch gap in between there so they don't overlap. Also, we don't want the entire flange here to come out behind this wall. We only need part of it. So we'll go ahead and edit. Instead of a full edge, we'll create a symmetric edge here. And I can go ahead and use these drag tools to bring it down, or I can specify that distance here. Now it gives me that support for this part as well. So now we don't need to weld this sheet metal. I'll go ahead and create the same for these sides as well. And as well as for this side. Now keep in mind that we are in a software multi-tool that has not only the sheet metal creation, but it has direct edit modeling that you can use at any time. You have parametric modeling that you can easily hop to, as well as surface modeling. Okay, so now we have most of the box created. Notice this box earlier, I actually created it a different method. I pulled this design history bar down here. Notice how I just created a corner of this, and then I did 2 mirror techniques to create that part, as well as a combined technique. So there's a bunch of different ways you can approach not only sheet metal, but just modeling in general. And this was just one of the ways that I found to be faster, because also you can edit, for instance, one of these features, and then it will edit the other 3, for instance, this flange. It will edit the other 3 flanges as well. So there's a bunch of different ways. But if this was like an L shape, for instance, the mirror feature might not be the best option. Also, I also added parameters in this feature as well. So if we look at the sketch of this one, it's referencing what we call parameters. And these parameters, if I go here to parameters, we discussed parameters in a past Fusion 360 video. We can edit the height and width of this box just by changing the parameters here without having to do some direct editing to the body. We just did it just by changing variables. And I just made it smaller there. So going back to the one we're working on, let's just create 1 tab each on the top here instead of 2 on each side, just to save time. And we'll go ahead and use that same symmetric flange. However, there's also the 2 offset flange. So if we were to create 2 flanges or 2 tabs on these sides, we would use the 2 offset feature. We'll go ahead and use the symmetric feature. And once again, we'll do the same to the other side. We can also add some fillets to this feature as well. We're not constrained to just flanges. Also select the other side. And we can add some holes. And there we go. Now let's hop into, or before we hop into the sheet metal rules, let's go ahead and let's edit the sheet metal using an extrude cut. So if we go here to unfold, we can unfold to see what the sheet metal looks like before we bend it. And we can also create a slot cut in this environment. We can create it in the folded environment as well, but I want to show you guys an example of what it looks like in the unfolded environment. So I'm going to go ahead and refold that, and you can see the change that has been made and how it applied that sheet metal rule or that curve to this slot cut there. And this is a tip, guys. If you're trying to create a slot cut like I just did, it works in the unfolded environment, but it doesn't work in the create flat pattern feature. That's its own environment per se. So just keep that in mind when you're trying to create a slot or any kind of cut to your unfolded feature. Make sure you're in the unfolded environment and not the create flat pattern environment. Excuse me. Okay, so now let's go ahead and edit the sheet metal rules. Now this is very important when working with sheet metal. So right now we're using the aluminum in inches that we were referring to earlier, or that we selected earlier. You can create your own rule as well. Like for instance, if you want to use sheet metal for cardboard, you can do that as well. And you can rename it. We have a few things we can edit here. First off is the thickness, how thick you want the part to be. Next we have K factor. Now this is very important in sheet metal, and in Fusion 360 everything is set to 0.44 a ratio. However, that's not always the case in real life. The K factor is depending on either the material you're using as well as the tool you're using to bend the sheet metal. For instance, you can be coining, or you can be air bending and things like that. There's also make sure there's ways online you can find your K factor. So make sure you have the correct K factor, because that lays out the neutral line to where your part should be bent. There's also the miter thickness, so that would be for the miter you saw earlier. It would be the how big that gap would be. There's the bend radius. If you see here, it's when I use the bend command in the beginning. That's how I can control that. I can go ahead and change that to I'll change it to half the thickness. I can also change it from being round to straight for the relief shape, and that would affect. Right now it's on round, but if I change it to straight, you'll see the difference there. And there's also more detailed 2-bend and 3-bend intersections, which we won't go too far into today. So I'll go ahead and hit save, and notice how it gave me half of the thickness here in the corner, and also gave me a straight relief bend instead of a round one. So once I'm happy with my sheet metal model, I'm going to go ahead and create a flat pattern. And this is going to be used for creating drawings and for machining. So now I have a flat pattern, and this is different from the unfold pattern, or the unfold tool, because I can see bends now with these turquoise colored blue lines. So in this environment, after we have this environment, I'm going to go ahead and start to create a drawing. And I'll go ahead and name it. And now, just like creating any other drawing, we can choose our sheet size, what standard we want to be in, what units, and so forth. So we can go ahead and place the flat pattern part there. We can also place a folded version of the model here. And the thing that changed about the drawing feature is that when you insert a table, it gives you it automatically fills out a bend table for you, and it shows all the bends here on the flat pattern, and it tells you what direction it should be bent in. Also, you can rename the order or renumber the order in which these are being bent. So for example, I'm changing it one at a time right now. Starting from 1, going all the way to 10. And then for good practice, it's good to make these all facing the same way and easily visible for the reader to view. You can also dimension the part, which is very important in the drawing. So then the person bending this will know how far or where exactly they can create that bend. And I won't go into dimensioning each one, but that's the general idea. There's also the ability to change your sheet size. Even though you created your entire thing and you're done and you want to change the sheet size, you can do that down below here. And you can also insert your own custom title block as well. If your company uses a particular one, you could input and bring that into Fusion. And if this was a sheet metal assembly, we have multiple sheets as well. Okay, let's go back to, now let's go ahead and create some tool paths for this in the CAM environment. So now we're in the CAM environment, the tools all changed. We'll go ahead and open this up, and now there's an option for a flat pattern. So we're gonna go ahead and activate that flat pattern. And now we can go ahead and start creating our setup and tool paths. So we'll work with that left to right workflow that Fusion is known for. We'll go ahead and go up here to the setup, and it automatically selected an outside stock for this. It changed the operation type to cutting, and usually it's like milling or turning, but it recognizes that's a flat pattern, and we're gonna do a cutting operation on this. I'll go ahead and change the width and height offset to, but adding 1 inch, and I'll turn the stock top to 0 because we're not going to be facing it or anything like that.
Right. Notice too that it's by default a relative size box, right? So you can essentially create the stock for let's say you have a larger sheet of sheet metal, right? You can essentially just add the dimensions for your material, and then visualize how it's going to look from that size sheet that you have, right? You can also create patterns from this if you want. So just lay out your entire sheet, create a linear pattern for your tool paths, and then watch the simulation go.
So now we can go ahead and create that 2D profile of this using this cutting panel here. And just like any other tool, or any other tool path creation, we first select the tool. I'll choose a 0.5 millimeter water jet tool. We can go ahead and select the geometry we want to bound our tool paths in. And also, I'm going to add this feature called tabs, and this adds tabs to our part. Fusion automatically adds tabs for us, and we can adjust the settings for that here as well. And lastly, I'm going to go ahead and update the lead-in distance to 20 thousandths of an inch, so it doesn't lead in from too far away. And we'll go ahead and hit OK, and it quickly updated that for us, and we'll go ahead and simulate what this tool path will look like. And we can see how long this will take. And once we're happy with this tool path, we can go ahead and post it. So I'll go ahead and grab that, post it, find your water jetting tool, or your post processor, I mean, and then you can go ahead and start machining that. So yeah.
We got a question here from Jeff. It looks like he's asking,
sure.
Do the same changes apply to sheet metal? So I'm guessing what he's trying to ask is, if this change that you make to the sheet metal part, is it going to apply to the CAM portion of Fusion?
Yeah, so that has to do with the Fusion 360 CAD CAM integration. So whatever you do to the CAD environment, it's the same data. So this is essentially the CAD data that you see here on the screen. And so if I, for instance, make this flange a little bit longer, it will come in here. It'll tell us to update it. But once you update it, then we can update the tool paths as well, and then it's pretty much good to go from there. If that answers your question.
Yep. Looks like it does. Cool.
All right, so we'll go ahead and go back to the PowerPoint here. So, excuse me. So I just showed you guys how to create a sheet metal from scratch, how to create the flat pattern for it, how to fold, unfold it, create drawings from it as well as create tool paths to cam it. So pretty much the whole entire process from design to fabrication right there. We also have a service called Fusion Boost, and what this is, it's pretty much Fusion 360 training, and it comes with an introductory call from one of our Fusion 360 experts here to get you up and running with Fusion 360 and to tell you guys how your settings are work, how your data is stored, and just the best solutions for those. We also have a fundamentals training once a month for Fusion 360 basics. We also have a technical assistance. So these are 4 sessions up to 1 hour each with our Fusion 360 experts. We also have a wellness check. So if we haven't heard from you guys in about a month or two, we call up or we email you guys to follow up on that. And lastly, we have our webinars like Fusion Fridays and our meetups that we have, usually local to Southern California. Here are the pricing for Fusion Boost. So the first tab here is just Fusion 360 standalone without Boost, and that's $300. Fusion 360 with Fusion Boost, so this comes with a seat of Fusion 360, is $499. And then the Fusion 360 Ultimate with Boost is $1799. So reach out to us, email us, call us if you're interested in those, or if you're interested in talking about or giving us feedback on the next Fusion Friday. So yeah, let's go ahead and answer any questions you guys may have.
Yeah, so looks here like Greg is asking, how would you model a sheet metal cone?
A sheet metal cone?
A sheet metal cone. So that's a good question, Greg. Let me take a look here. It's not a very intuitive way to go about it, but let's see if we can knock one out here. All right, so let's go into the sheet metal environment. Let's create a line. Just create a basic line.
Let's see if we can stump the trainer right here.
So of course, I'm not going to dimension this. Just an arbitrary flange. All right, just extrude it, string them out.
And if you guys missed some of this Fusion Friday video and you want to see like the first half, feel free to check us out on YouTube. If you type in KETIV Fusion Fridays, and we'll have this video up before the end of next week.
All right, so let's see if this works. So essentially what I created here was a pretty small slit in order to get the profile going. So now let's go into the modeling workspace. Let's go ahead and reload this profile. This axis. Okay, we don't want to cut, we want to join it, and we don't want to go full 360. Let's go 345.
So essentially, Alex is not closing it, so then the sheet metal environment can recognize that it's sheet metal.
So now let's go ahead and unfold this. Let's see. Unfold it. So now the stationary face, we can go ahead and use the one that we created. We want to unfold all bands. Go ahead and click OK, and we should have the profile. Okay, so essentially that's how you would create. You can create a cone. Again, it's not a very intuitive way to go about it, but gets the job done. All right, so it looks like we have a couple questions here describing the pricing for Fusion 360. So Brian, if you want to go ahead again and
so Fusion 360 standalone, so without Fusion Boost, is $300 a year, and not per month. It's $300 is a year. Yeah.
All right, it looks like Mohammed has a question here as well. Can you drag and drop different flat pattern parts all into one sheet? For example, you're running 2 of the same parts and 1 different one.
Can you drop 2 flat patterns on the same sheet?
Yes. If I understand correctly, Mohammed, you're talking about the cam portion of it. So essentially, you want to create a cam setup for 2 of your different components. Yeah, absolutely. Yeah, so you would be able to essentially create your parts there. Oh, you know what, you wouldn't. Yeah, no, that wouldn't be possible because you do have to select which flap pattern you're going to activate. So if it is just going to be, if you do have two different ones, you can only activate one at a time. But as I was saying earlier, if you do have two of the same components that you want to go ahead and cam out, go ahead and create a pattern of the toolpaths that you have created. So if you go over here to the top, go ahead and new pattern. So make sure that you have your toolpath selected. And then select new pattern, and then that's going to pattern the toolpath for the same component that you have laid out. But unfortunately, yeah, you can only have one component or one flat pattern active for your cam setup. Okay.
All right. Looks like that's it for the questions.
We'll give it a few more seconds here. All right, guys. So again, thank you for tuning in. Like we mentioned, we are going to be hosting these Fusion Fridays every other week. Our next one is going to be January 5th on setting up your tool library, and a new function actually inside of Fusion 360 is the custom form tool, right? So we're going to be going over some of those steps. So thank you guys for joining us. Have a good weekend.
Yeah, happy holidays.
Yeah, see you guys